All right, today we're tackling something big, AI's big memory test. We ask our AIs to do all this incredible stuff, right? Write poems, churn out code, but there's always been this nagging question in the back of our minds. Is it actually a genius, or is it just a really, really good mimic?
Well, today we're going to dive into some amazing new research that finally gives us a way to tell the difference. A real yardstick to measure what an AI actually knows versus what it's just memorized. So here's the problem in a nutshell. When a language model spits out a perfect answer, how do we know if it actually figured it out, or if it's just copying its homework from something it saw in its training data? We've never had a good way to tell for sure.
And this quote from the paper just nails it. Think about it. If you ask an AI, what's 2 plus 2, and it says 4, did it learn addition, or did it just memorize that one specific equation? See, just getting the right answer isn't enough proof. It could be simple memorization, or it could be a sign of real, honest-to-goodness understanding.
And that really brings us to the two big ideas we need to unpack here: memorization versus generalization.
Okay, the easiest way to get this is to think back to school. Remember studying for an exam? Memorization? That's just cramming flashcards. You know the exact answer to the exact question on the card. But generalization, that's when you actually get the subject. You can walk into that test and solve problems you've never even seen before. That's the difference. So, researchers have a name for the bad kind of memory we're worried about: unintended memorization. This is basically just useless trivia the model picks up. It's a specific, raw piece of information about one single thing it was trained on. It's not a useful pattern, it's just a factoid it happened to squirrel away. Generalization, though, that's the holy grail. That's the good stuff. It's the useful, abstract knowledge that lets an AI actually be creative and solve new problems. So the million-dollar question is, how in the world do you measure one without getting tricked by the other? And this is where things get really cool. This is the big breakthrough. To crack this problem, the researchers took a classic old-school idea and used it in a totally new way.
What was that idea? Compression. Yep, the same concept behind zipping a file. It's all about making information smaller.
And the logic here is just brilliant. It goes like this. If a model has memorized something, say a paragraph from a book, then it should be able to help you compress that paragraph into a tiny file. Why? Because it already knows what's in it. The better it can shrink the file, the more it proves it had that info stored away. It's a direct mathematical way to measure what it's memorized.
Okay, so now they have this amazing new tool. The big question is, what did they find when they actually used it on today's big AI models?
The first discovery is a big one, and it's super fundamental. AI models do not have infinite memory. They're not bottomless pits of information. There is a hard, physical limit to how much random stuff they can cram into their digital brains.
And they actually put a number on it. They calculated that limit. For models like the GPT family, that memory capacity, that space for useless trivia, is about 3.6 bits for every single parameter. It's like they found a new fundamental constant of the universe, but for AI.
And you can see that limit right here. As they fed the models more and more data to learn from, the amount of stuff they memorized just kept climbing, and then boom, it flatlines. It hits a plateau. The model's memory is literally full. It just can't memorize any more raw facts no matter what.
So, that leads to a really fascinating question, right? What happens next? What happens when the AI's memory is completely full? Well, something really weird happens. It's a phenomenon called double descent, and it's totally counterintuitive. First, right when the model hits that memory limit, its performance actually gets worse. It starts making more mistakes. But then, because it has no more room to just memorize facts, it's forced to get smarter. It has to find a more efficient way to store all that knowledge. And how does it do that? By finding patterns. It's forced to generalize. And then, all of a sudden, its performance shoots way up.
Just like the researchers say, hitting that wall, that memory limit, is the key. It's the pressure that forces the model to stop being a parrot and start being a problem solver. And this finally explains this bizarre learning curve that's had scientists scratching their heads for years.
Okay, so this is all really interesting, but what does it mean for us in the real world? This is way more than just an academic exercise. This has huge implications for how we actually build and, maybe more importantly, trust AI.
And the biggest one is data privacy. Remember that unintended memorization, that useless trivia? Well, what if that trivia isn't so useless?
What if it's your private email, or a company's secret formula, or your sensitive medical records that got swept up in the training data? This is where it gets really practical. They found a clear rule for privacy risk. Look at this. If you have a giant model with a ton of memory, but you only train it on a relatively small amount of data, the privacy risk is super high. The model has all this extra space to just memorize personal details, which makes it easy to attack. But, and this is the key, if you train a model on a massive dataset, one that's way bigger than its memory capacity, the risk just plummets. The model literally doesn't have the space to remember individual details, so it's forced to forget them and just learn the general patterns. So let's just recap the big takeaways here. First, AI models have a finite memory, about 3.6 bits per parameter. Second, hitting that memory limit is what actually forces them to get smart and generalize. Third, this whole thing explains that weird double descent learning curve. And finally, and maybe most importantly for us, the privacy risk of an AI all comes down to one thing: the ratio of its memory size to its training data size. You know, for the very first time, we can actually put a number on what an AI memorizes. We can measure it, and that leaves us with a pretty incredible thought to end on. Now that we can do that, can we finally build an AI that's incredibly smart and creative, but is also designed from the ground up to be physically incapable of ever leaking a single secret?